Now that we've got our definition of remote sensing, let's dig down into it and see what each part means. Let's start with this phrase, acquired from an overhead perspective. Some of the first remote sensing was done by people strapping cameras to pigeons, literally to get a bird's eye view over a city. Kites were often used, still are. Things like hot air balloons, sort of harking back to the 18th century or 19th century, right? Nowadays, we have things like drones, or UAVs, unmanned aerial vehicles. Those can be things like quad-rotor drones that you might see in the park or recreational users using, just flying around between maybe 5 or 50 meters. It might be a fixed-wing UAV, basically a small little airplane with 1.5 meter wingspan that can go up much higher, maybe even over 1,000 meters. Airplanes are often used, small airplanes, 1-2 seat aircraft with a sensor fitted on. Those are flying, of course, depends, but maybe 3 or more thousand meters. In this course, we're going to be focusing, of course, on satellites. And satellites are well above that, in hundreds of kilometers in outer space, flying above the Earth, giving a true space bird's eye view of what's going on down here. So I thought it'd be interesting to give you a feel for just how high satellites are and where they're at, how their orbits are, by looking at a really cool app. That app is called Spacebook, which is kind of like Facebook, I guess, for satellites. It's produced by AGI.com, and it's incredible. They are using publicly available data on all the locations of satellites, the orbits, decommissioned satellites, rocket bodies, space debris, other things like that. So right here in the middle, it's hard to see, but this is the Earth right here. If you look at this ring around the outside here, these are geosynchronous satellites, which are in the same position over the Earth every day. If we zoom in a little bit, looking at our area of interest here in Southeast Asia, you can see another shell around the Earth, I would say, of sun-synchronous satellites. These appear over the same part of the Earth at the same time every day. But let's look at ALOS. That's our sensor or our satellite of interest carrying the Pulsar sensor. So let's type that in. You can look at ALOS 2, or I guess just ALOS. And then, 2 come up. This first one right here is the previous ALOS, ALOS 1, which was called Daiichi. That's been decommissioned. And then there's the other one right there. Yeah, this is ALOS 2, I believe. Yeah, ALOS 2. This is the current one that's carrying Pulsar 2. So if you want to, let me clear that away. If you click on that little button right there, there it is. And also if you look down here and click on the simulation button, that'll start moving forward. And this shows you where the satellite is at the moment that you click. It shows the actual orbit, right? So this is really amazing. And what I'm going to do now is turn that off for a second and sort of pan around here to give you, and this is a little bit tricky actually, but to give you an idea about just how high the satellite is. ALOS 2 is at 628 kilometers. And if I get this right, let me pan. Wrong way. Okay, pan up this way. Yeah, so that's what 628 kilometers above the Earth looks like. Other sensors we'll be talking about Landsat, that's 705. Sentinel-2 is 786 kilometers. But right here, ALOS 2, it's flying near the Philippines right now. It's sending down a radar signal, which is bouncing off different land types. It's being backscattered back to the satellite and becoming the data that we're going to be making use of.